Let's solve some numerical problems on diffraction. The first problem is a single slit of width 0.15 mm is illuminated normally by monochromatic light. The diffraction bands are observed on a screen which is 1.5 cm away from the slit. If the center of the second dark band is 1.4 cm from the central bright band, find the wavelength of the light used. To understand this, let's draw the diagram. This one is the single slit, and here is the screen. And on the screen, we get central maxima at this point. Then there is a first minima, first secondary maxima, and then second minima, and so on. So at this point here, we get the second minima. So this angle over here, at this point, we are getting second minima. Let us say the angle is theta. And the distance between the slit and the screen is, let's say, capital T. And distance between the second minima, at this point what we get is the second minima, and the center of central maxima. This distance is equals to, let's say, x. The distance between the second minima and the center of central maxima is x. Then let's see what is given. A single slit of width 0.15 mm. So A is given, which is 0.15 mm. Let us convert this into centimeter. So that is 0.015 centimeter. Then the diffraction bands are observed on a screen which is 1.5 centimeter away from the slit. So the capital D is given. Capital D is equals to 1.5 meter. Let's convert this in centimeter. So that is 150 centimeter. If the center of the second dark band, that is the order is given of the minima, that is m equals to 2, is 1.4 centimeter from the central bright band. So the x is also given. X is 1.4 centimeter. So these are the given quantities. From the diagram, you can see that what would be tan theta? Tan theta is equals to x upon capital D. X is given 1.4. D is also given 150 centimeter. 1.4 centimeter by 150 centimeter, and that is equals to 0.00933. But that is tan theta. So theta is equals to tan inverse of 0.00933, which is equals to 0.5347. You can also consider, since the theta is very small, you can consider tan theta equals to theta and directly take this value. But anyway, we are calculating the theta, which is 0.5347. Then the equation for minima is A sine theta is equals to m lambda, where m is the order. And what we have to find is the wavelength. So wavelength is equals to lambda is equals to A sine theta upon m. A is given 0.015 centimeter into sine theta. Sine of this is the theta. So sine of 0.5347 divided by the order, which is 2. Now this is equals to 0.015 into sine of 0.5347 is 0.00933 again, that divided by 2, and which comes around 7 into 10 raised to minus 5 centimeters. So this is the wavelength. Let's go to the sum number 2. A light of wavelength 589 nanometer falls normally on a slit width 0.0032 millimeter. Calculate angular position of the first two minima on either side of the central maxima. So let's see first what is the given quantities. The lambda is given, which is 589 nanometer, which is nothing but 5.89 into 10 raised to minus 5 centimeter. Slit width is given A. A is 0.0032 millimeter. That is nothing but 3.2 into 10 raised to minus 4 centimeter. So these are the given. And we know the equation for the minima. Equation for minima is A sine theta is equals to m lambda, where m is equals to 1, 2, etc. Now here we have given calculate angular position of the first two minima on either side of the central maxima. So there is a minima 1 and there is minima 2. So this m equals to 1 and 2. This is also given. So let us first write for the first minima. What would be the for first minima? M equals to 1 and theta is, let's say, theta 1. For first minima, M equals to 1, theta is equals to theta 1, and therefore the equation is sine theta 1 is equals to m lambda upon A. Now m is equals to 1. So 1 into lambda, that is 5.89 into 10 raised to minus 5 centimeter, divided by A, which is 3.2 into 10 raised to minus 4 centimeter. And that quantity is equals to, the sine theta 1 is equals to, after solving this, we get 0.184. Therefore, theta 1 is equals to sine inverse of 0.184, and that is equals to 10.603 degree. This 10.603 degree we can write as 10 degree, 36 minutes and 11 seconds. So this is theta 1. The angle for the first minima is 10 degree, 36 minutes, 11 seconds. Then let us find this angle for the second order. For second minima, m equals to 2 and theta is equals to theta 2. And therefore, this sine theta 2 is equals to m lambda upon A, that is equals to 2 into 5.89 10 raised to minus 5 centimeter divided by A is 3.2 into 10 raised to minus 4 centimeter. What we get is this is equals to this one is equals to 0.368 0.368, and therefore theta 2 is equals to sine inverse of 0.368, and that is equals to 21.5923 degree. This is equals to 21 degree 35 minutes and 32 seconds. So the first minima occur at angle 10 degree 36 minutes 11 seconds, and the second one occurs at 21 degree 35 minutes and 32 seconds. And what is asked? Angular position of the first two minima. That is what is asked. We asked for, it is asked minima, angle for first minima and angle for the second minima. Angle for the first minima is 10.603 degree, and this is angle for the second minima. Then let's go to the problem number 3. For an offered diffraction pattern of a single slit of width 0.3 mm. So here what is given? A is given, which is 0.3 mm, and that is equals to 0.3 into 10 raised to minus 3 meter. So this is given. Using monochromatic light of 600 nanometer. So the lambda is also given. So lambda is equals to 600 nanometer, which is equals to 600 into 10 raised to minus 9 meter. Calculate the angles at which the first dark band and the next bright band is formed. So we have to find theta 1, let's say, for first minima, that is first dark band, and we have to find theta 2 for first secondary maxima, that is bright band. So this is what we have to find. Now we know the equation for the minima. Let us first find minima angle. So for minima, A sine theta is equals to m lambda. In this case, m equals to 1. Then, and theta is equals to theta 1. Theta is equals to theta 1. Therefore, the equation is sine theta 1 is equals to m lambda upon E, which is equals to 1, m is 1, into lambda, which is 600 into 10 raised to minus 9 meter, divided by A, which is 0.3 into 10 raised to minus 3 meter. And this is equals to 2 into 10 raised to minus 3. So sine theta 1 equals to 2 into 10 raised to minus 3. Then what would be the theta 1? Theta 1 is equals to sine inverse of 2 into 10 raised to minus 3, and that is equals to 0.1146 degree. and 0.1146 degree is equals to 6 minutes 53 seconds. So we got the theta 1 for the minima, first minima. Then for maxima the equation is a sine theta is equals to 2n plus 1 lambda by 2. In this case, n equals to 1, and therefore here n equals to 1 and theta is equals to theta 2. Therefore, sine theta 2 is equals to this n equals to 1, so that is 3 lambda by 2 by a. 3 lambda upon 2a. So sine theta 2 is equals to 3 into lambda. Lambda is 600 into 10 raised to minus 9 meter divided by 2 into a. A is 0.3 into 10 raised to minus 3 meter. So this comes around 3 into 10 raised to minus 3. Then theta 2 is equals to sine inverse of 3 into 10 raised to minus 3, and that is equals to 0.1719, which is 10 minute 19 seconds. So that is what was asked. Then let's go to the sum number 4.